Right, hello again. So this is where we were at the end of last week, only I've taken a bit about the mean up there, because the first thing I wanted to do was draw attention to the fact that we're going to be doing some other sorts of probabilities. Last week we were just looking at what happens if you're one standard deviation or two standard deviations or three standard deviations away from the mean, and it gives us these predictable probabilities. However, what happens if you wanted to know what was the probability that happened to be just this far up? What do you do? Well, we've got a nice little trick we can do with the calculator, but before we do, I need to make you aware that when we're talking about normal distribution, the mean often isn't written as x bar. So the mean can equal x bar, but when we're talking about normal distribution, more commonly it's another Greek letter called mu, something like mu, not exactly sure if that's the right pronunciation, but anyway, that's what it is. So write that one down, have a think about it, well, just try and get it into your head, and I'll put your next question down. Okay, here's our little problem. Tuck into that whilst I tuck into, well, write it down whilst I tuck into this lovely little chocolate macaroon. Don't know where you stand on macaroons, but lovely coconutty things that they are. And then you're going to need to dig out your scientific calculator. Now there's not a lot to do today, so I'm going to take my time taking you through how to put it into the calculator and write it down so that you've got something really clear to go back to. So first of all, you go to menu, you want statistics mode, don't you? So it's menu, statistics. That's the first thing. Now the second thing is we're looking at the normal distribution. So looking along here, graph, no, okay, dist for distribution. So dist for distribution. Then third thing, we want the normal distribution. Now we've used a binomial, but over here you've got the normal. So F1 for norm. Moving on from that, you've got a choice of these two. Now the C stands for continuous, so this is what you want. So NCD, that means we're going to have the cumulative stuff going on. We can get everything that we need from there. So it's a little bit like what we've done with the binomial before. We've got a lower value, an upper value, we've got the standard deviation, and we've got the mean there. So first up we put the lower value as we're going up to 33, so it's below 33. So if we go for 0 on that, keep that there. Ooh, exit that, right, so just go down to there. Then the upper value is going to be 33. Then we're going for the standard deviation. So standard deviation, remember, is the 4, not 4 squared. 4 squared is the variance. So that's 4. Then mu, that is the mean, which is our 30 there. So pop in 30. And then press execute, and you get the probability there is 0.7337. So always do these to 4 decimal places. I know normally we're 3 significant figures, but it's 4 decimal places, and that's because it comes from the fact that any tables we've got, and we've still got some tables that we use in the formula booklet, they're always done to 4 decimal places, so that's why we go for that. Right, now that you've got that, you should always check that what you've got seems like a sensible idea by doing a wee sketch. So there's my bell curve. I've got 30 is going to be there. 33 is going to be a bit more than what we've got going on. And so 33 we can put in like that, and we're looking at this. So does 0.77, 77% seem reasonable for that? Yes, it does. So we're happy and we can move on. Second problem, there it is. x is bigger than or smaller than 24. Have a little think. What do you reckon? Pause this and then there we go. Now you may be wondering, you may have got to the point of wondering, what's going on with the or equals than? Now, because it's continuous data, that means the probability of it being exactly 24 is kind of everything's going right up to the point of it. So you don't need to worry about that. You can just go the same as if it was saying what's the probability that's above 24, because it's just one cut-off moment in all the space of what's going on there. So our lower value is going to be 24. Our upper value, well, yeah, what's your upper value? Just go for something massive. Since we've got 77% there, it's all going to be over by sort of 40-ish, not exactly sure. So I'm just going to put 1000 in there for the upper. It's definitely going to be enough to cover everything. Then pop the standard deviation. Oh, that's already there, isn't it? And so we go then for 0.93319, means that rounds up to 2 to 4 dp. Don't know why I've just written dp there, to 4 decimal places, and that's the same again. Is that sensible? Well, if I draw my bell curve again, 24 is some way below 30. It's further below 30 than 33 was, which is why it's a larger probability. That's all that is. We're just going to have 2 more to go, which I'm going to put on in a moment. So with the same normal distribution, have a go for C and D, couple of combined regions and a combined region. Pause the video, give it a go, see what you reckon. Okay, so you should have your lower value 33.5, your upper value 38.2, then everything else is staying just the same as it was. Press execute a couple of times and you get 0.1706 as a picture. What we're basically looking at here is, there's our 33.5 is sort of here, 33.5, and 38.2 is about there. So we are just looking at that sort of region there, and as one just about a sixth, that looks about right, doesn't it? Okay, now the one underneath that, if we go back, we are looking at 2 different zones. Now you've got a couple of ways you could do this. You could do 0 to 27 and 32 up to 1000 or whatever. Add those 2 probabilities together. If you do, be very careful, because if you just take the first 4 decimal places and add them together, you're going to be out by just 1 in the 4th decimal place. So you need to make sure you keep more than 4 decimal places when you're doing that. Or you can think of the fact that if we draw this one first of all, and what we're looking at is, there's 30, there's 27, there's 32. If I put a line in there, I want this and I want that. So I could find them both separately and add them up, or I could say that the probability of that is going to equal 1 take this region here. So that is, take the probability of between, what is it we're talking? We're saying bigger than 27 and smaller than 32, because it's the only other little bit left. So that saves us a little bit of time on in terms of what we've got to work out. So we've got 27 for our lower value, 32 for our higher value. Press equals, and if you did the first thing that I was talking about before going through, you may well have found yourself just out by one. We should have 0.4648 that we're going to take away from 1, which would give us 0. Let's make sure we don't mess that up. 1 take 0.4848, and that gives us 0.5152. And I think you'll find if you had done that thing of just keeping it to 4 decimal places, that would have got you wrong by one tiny little bit on that. You would have got a 1 there instead of a 2, or it might have been a 3, don't know. Anyway, I said that was all of the example. That's all of the first example. Actually, we've got another little one to look at, so hold on, folks. Right, so here's a problem that I'm sure you can all sympathise with. The whole idea of, so I know I'm a genius, but what was the probability of that being true? And the second part of this problem, what's the probability that I'm the only genius in the room? These are the sorts of problems that we want to sort ourselves out with. So write this down, pause the video and have a little go, and then see whether or not you're clever enough to have worked out what you should have done. So, the probability that an adult chosen at random achieves a genius classification is 100. And the standard deviation for that is 15. Sorry, I think I might have just said that all not as genius, Liz. The mean score for an IQ test is 100. The standard deviation from the mean is 15. So either side of that, between 115 and 85, that should be 68% of the population. And then if you go 2 standard deviations, you get 95%, don't you? That's up to 130. The genius needs to be 140. So what is the probability of that? So we are looking at the probability that x is bigger than 140, and in order to work that out we just need to pop along to statistics mode and distribution, normal, NCD. Our lowest value possible is going to be 140. Our highest, well, put in 1,000. It's not possible to score 1,000 on an IQ test, so it's definitely more than enough. The not the mean, the standard deviation, oh, that is 15. And oh, come back. And the mean is 100, so that's nice. And that's giving us a probability of 3.8304 times 10 to the negative 3. Now we've been asked to leave it to 3 significant figures, so let's convert it out of standard form. So that'll be 0.0123123, 123. Yeah, do that like a genius. 0.038. Now normally that would be enough, wouldn't it? But we've been asked for 3 significant figures, probably because we've only got 2 significant left, because it's so unlikely that to find someone as clever as us. So that is 2, 3 significant figures. Now the second problem, when they were told 20 adults take the test, we need to find the probability that 2 or more of them are classified as genius. All of a sudden this is no longer a normal distribution problem, is it? This is now a binomial, because we've got 2 things that can happen. Either you're a genius or you're not a genius, and we know the probability, and we've got a set number of tests to do. So we can say that we've got a binomial distribution where our probability is 0.00383, and the number of tests are going to be 20. So what's the probability that there are 2 of you in the same room of 20 people? And in order to do that, we need to come out of where we were, go to Distribution, Binomial, BCD. Lower is 140. The upper, may as well go to hang on, that's what we had from before, isn't it? Binomial, we want the lower to be 2, and it says 2 or more, so our upper will be 20. Our number of trials is 20. Our probability is 0.00383, which is what that is already. Press that in there, we get 2.66 times 10 to the negative 3, which will convert by dividing by 10 3 times, gets us 0.00266 to 3 significant figures, which is an appropriate one to do as they asked it in the very previous question. And that's all for the examples for today. So now, in order to practice this, you want to go to page 43, exercise 3B, and have a crack at questions 8, 9, 11 and 12. And if you can get through those without too many problems, then you're well on the way to having mastered that little section, finding probabilities from a normal distribution. Farewell.